Can you hear me now? Okay. Let's start over. I'm sorry. My name is Eugene Cook, and this talk was originally supposed to be over an hour long, so I've had to condense it down, so I apologize that there aren't more examples. But what I really want to do is go through and database theory from the beginning to end very briefly, and also at the very end compare and contrast the approach to SQL databases and how to utilize that data architecture within your program to NoSQL, and why and when you would choose one over the other. Because right now, Mongo, Rethink, et cetera, it's really hot in the web sphere. Why is it hot, and how does it differ from traditional SQL databases? And I mean, I'd venture to say in the PHP sphere, 90% of the application work happens in a SQL database. So it's going to be interesting as PHP kind of charts that new frontier. So just a little bit about me. I am a transactional lawyer. I'm licensed in the United States. I've been a programmer for almost 20 years, however, and I'm what I call a polymathic technologist, which is I try to have a functional fluency in as many technologies as possible, especially new emerging technologies, so I understand where they fit within the development sphere. So, like we just talked about, there's really two primary trends in DB design. There's schema-based, which is MySQL, MariaDB, Postgre, and obviously on the NoSQL side, stuff like Mongo, Rethink, Redis, and Google Bigtable. Now, the primary difference is, number one, of course, you have to kind of pre-plan all of the tables ahead of time in MySQL, as opposed to NoSQL, everything is more of a document-based. You can actually store stuff as an array. Everything that happens in a SQL database is, each cell is atomic, whereas in the NoSQL side, it is a document which can be multifaceted, multi-layered. And I'll get into that in just a little bit, but I just wanted to kind of broadly declare that. And here's what's interesting, and this is something we'll touch upon a little bit more, but just because they call it a schemaless database, that isn't necessarily true, but we'll get into that. So, a quick primer about data modeling. Some of you talked about, you have been in charge of actually looking at the data and creating the database from the ground up. So I know a lot of people, especially if you use WordPress or Drupal or something like that, the database is largely already there for you and architected for you. But I just wanted to go over the core concepts of data modeling and database design just really quickly so it makes sense and we can contrast that against NoSQL. So the first step in database architecture is obviously the data modeling, taking the scope of the application and understanding what are the logical objects. So identifying the distinct entities that comprise your data, conceptualizing the data objects, and identifying the relationships. And this is just on a broad level. You can even just draw it out on a piece of paper. But then you have to convert that into the actual database design. So it's the conversion of the data objects into an actual schema, naming convention of your data and the relationships, and deciding what constraints you should have. So I'll just go through a real quick example of this process. So the project scope. You've been asked by Headmistress Gertrude to create a system for her new boarding school. She wants to be able to track the student schedules and also their financial status. Seems pretty simple. So of course you budgeted and you bid, $1,000 US, and of course it ended up taking you, in the end, 2,000 hours, which is like most jobs. But what are the logical objects? Courses, enrollment, grades, account, students, teachers, these types of things. You've kind of worked it through in your head. So how would these look? Let's go ahead and look at the student table. And so most people, whenever they first start designing out a database table, especially if they haven't done the architecture before, it seems pretty simple. You have a giant monolithic student table, and you just list the students out in each row. Of course, each row is a record, and each column is an attribute. You guys are already familiar with that. And so class 1, grade, class 2, grade, how much is due, and when, maybe what month they last paid. So this is typically, this is not normalized at all, and this is kind of where most people start. That was easy. Any questions? We're done. Application's done. No, so Gertrude, of course, does not approve. She is not happy about this one bit. She asks, what about next semester? What if they take more than 2 classes? How do we save more information about the classes, more metadata about the classes themselves? Well, these are actually very good questions, Gertrude. Back to the drawing board. I am not done. I thought I was done. So let's start talking about this. The 2 main processes within database design and converting it into a schema are normalization and cardinality. So normalization is organizing the tables and the columns to minimize redundancy. What does that mean? So of course you see here, there's law multiple times, social multiple times, and you have issues in that redundancy. For example, what if you had to change the name of social? You would actually have to go and change that every single time in the database. What if you had to change law? Same thing. And there's really no way to include any meta information about law, etc. So, and I understand for many this is really basic, but I just wanted to kind of establish that. And cardinality is the relationship of objects to one another. So, what about the class meta information? What if we change the class name? That's what we just went over. Okay. So we've separated out the classes now. You see that. And we've also added teacher because she wanted to have more information. But if you see up here, we still have law listed out. Now we could query that and do a join and we would have the teacher for law, but this doesn't really make sense. We're still there's still redundancy. So, let's start looking at relationships just really quickly. The primary cardinalities are the relationships are one-to-one, one-to-many, and many-to-many. Now within development parlance, this is the vocabulary. This is often referred to as belongs to and has one, depending on which side you're in. Belongs to, has many, or many, which is has many through, has many through. Now why is it called has many through? So just to show really quickly how you would identify the relationships. Classes to teachers. Can a class have multiple teachers? No, they can't. Only one teacher, obviously. Can a teacher teach multiple classes? Yes, absolutely. So it's a many-to-one, or depending which way you go, a one-to-many relationship. Very basic, very straightforward. So this is an example of the one-to-many relationship. So right here, we have a teacher who's separate. We needed to create a one-to-many relationship. So obviously up here, we've done that. Now, this is what's known as a primary key. For many people, again, I apologize, I know that's basic. And over here is what's known as a foreign key because we're referencing that primary key. So what we've done is actually broken teacher out as a separate table to create that one-to-many relationship. Now, if Susan changes her name to, let's say, I don't know, Trisha, we don't have to change it multiple times in the database. This is normalization. So real quickly, many-to-many. Can a student be in multiple classes? Yes. Can a class have multiple students? Also, yes. But how do you capture that within a database? And the key is the relationship itself is within its own table. So you see up here, the students, 1, 2, 3, 4 primary key, and then the class, 1, 2, 3, 4 for the names of the class, and then the relationship itself is listed out in the relationship table, enrolled in. Student 1 is in class ID 2, student 1 is also in class ID 3. And what that allows you to do is have 0 to many classes. So all of a sudden, a student can be in 0, 1, 2, 5, 7, 10 classes. That's breaking it out, and that's creating a relationship table respective of the cardinality, the many-to-many relationship. Now, whenever you're designing the table, a lot of times you're not going to go directly in and create the schema, the SQL right away. So you create what's called an entity relationship diagram, and this is really, really good. If you have a new application that you're trying to develop, you need to do this first. You need to break it out and logically think through what the objects are and what their relation is to each other. And as you can see here, this is kind of a same example we were looking at. Departments, classes, students, classes. This is actually a relationship table for a many-to-many relationship. which also has, coincidentally, a grade you can attach to it, because even the relationship can have metadata. So, what do these mean though? Right here are what we call crow's feet, and it just indicates what kind of a relationship they are. 1-to-1, this is 0 or 1. Many is just the actual crow's feet, which is this, 0 to many, and then 0 to many, 1-to-1. Makes sense. So you can quickly visualize those data relationships. The nice thing about many applications that do this, there's a wonderful one called FabForce that's free for Windows, is that after you create this, it will actually create the SQL statements and create your data structure for you. So once you do that, it's automatic. There's also some applications that will take an existing schema, existing database, and convert it to this for you, so you have kind of a head start if you already have a database that you're working with. It's called FabForce. On the Mac, I think I use something called Navicat. It is a commercial program. It's not free, but it's also pretty competent. So, we've kind of gone through that. Let's go ahead and look at, now that we've gone through that primer, let's go ahead and look at optimization. So one of the three primary ways to look at optimization are to optimize your database, especially for queries, as your database gets larger, because everything works whenever you first start. Everything is fast whenever you first start. It's amazing. You do a query, split second. All of a sudden, 5 years down the road, you have 300,000 records, and your queries are taking brutally long. What's going on? And so, three of the primary ways to optimize your data in an existing database are through indexes, stored procedures, and views. So, indexes are probably the easiest one. And what an index is a highly efficient copy of select columns, which typically include a direct memory address or a direct disk address to the record. This makes it much, much, much quicker to do certain queries, and I'll show you an example of that. Stored procedures are routines that are run within the database that can sometimes be more efficient, and reduce DB traffic. And stored procedures are especially useful as more and more of us use external databases and create stateless applications that follow 12-factor. So let's say you have an external database that you have an external connection to on Amazon. You really want to try to reduce a lot of the DB traffic, and you want to try to manipulate most of it internal to the database. So that's one way that stored procedures help a lot. And then also views. Now views are interesting, because if you've ever done a join before, you join multiple tables together into a single set of data. The database can actually do that for you automatically in a view and make it its own table that you can query separately. So the stored queries of data which can be indexed separately, and in some databases, the resulting data set is indexed as a cluster, dramatically increasing performance. This is the key. So those views are actually cached along with the other tables. So if you have, let's say, an InnoDB cache, stuff like that, you can increase the InnoDB cache, and it's actually going to cache those views for you, and they're completely dynamic, which is really, really, really critical. All of a sudden, you can pull from joins as if they're an index table in itself. That dramatically increases the performance of joins in complex queries. So this was an example of an index. So create an index for attributes that you query the most. Indexes are updated dynamically and will result in dramatically improved queries. So in this case, I have a table, and I have, it just shows how an index works. But you have data: Smith, Jones, Smith, Williams, Plew, Glass, Smith, Wallace, Jones. Whenever you have an index, it actually goes through and creates a marker for Smith, and it tells the database exactly where in the table those locations are. So whenever you query for Smith, it doesn't have to go through the entire table any longer to look for Smith. It can actually just query the index, and immediately it knows the locations of those. This is the easiest way to increase the performance of your application. Figure out what you're querying most often and implement an index for it. Seriously, if you do it, a lot of those queries that are taking 10, 15 minutes may go down to a matter of seconds as a result, especially if your query set is large. So I think that's, let's go stored procedures and views. Now, I was going to provide an example of these, so just because due to time constraints, I can't really do it. But you should look this up, but create stored procedures for statically called SQL that manipulates or queries large data sets for subsets, or subsets. And I really don't have time to go into it more, but check those out. Those tend to be a little bit more advanced, and like I said, it really depends on what your application is and what the context is. But views, we talked about it earlier. Use views for common joins that you use all the time that aren't dynamic, and most of those will actually be kept in a separate table cache for many RDBSs. Okay, so let's go into kind of the fun stuff. What is NoSQL? Is it really schemaless? Maybe. So NoSQL databases don't have an internal schema. NoSQL databases are dynamically typed, meaning attributes can even have different types. Meaning within documents, in a SQL database, everything in the column for, let's say, amount might be an integer. In a NoSQL database, because there's no schema, just because you have an attribute that is the same name, one could be a string, one can be an integer, it's all dynamically typed. Now, it uses documents instead of records, which can be thought of as an object or an array. So everything in a SQL database is atomic, meaning it's just a singular string. But in a document, it can be an array, it can be multi-leveled, you can have an object within an object. And so it gives you a lot of flexibility. Documents have no inherent schema. From one document to the next, they can look completely different, have different attributes, and not look the same at all. So schema, constraints, and types then are all soft, meaning they rely on the programming or abstractions rather than hard in the DB. If you end up saving something into a NoSQL database that doesn't follow your quote-unquote schema, it's just going to save. If you do that with a SQL database, it will fail out. It will immediately knock it back and it won't save it. So why do you use it? The documents are very flexible. They iterate very quickly. They're more agile. You don't need to migrate the data to the new schema. You can have documents that have the old schema and new schema directly in the same quote-unquote table. Most of them have an interesting capability of reading the data as JSON or BSON, so it makes creating web applications very, very easy. And there's also this notion that's used ironically of web scale. Being able to handle the scalable traffic on an enterprise level. What's bad about it? So because of its distributed architecture, you sometimes have data fidelity problems. Soft constraints are programmatic, meaning you really have to program in the constraints to make sure you're handling and cleansing the data properly. The schema is not going to act as a fallback for you. Most NoSQL, they're not built for joins, and it requires optimization of writes for reads. Now, what does that mean? And that's really the key here. Web scale, 11D1.11, yes. Web scale is key. So web scale is delivering scalable, consistent performance, especially through distributed reads. Now, we just talked about normalization and how important normalization is. We get this through denormalization. Relational data is kept in the document itself rather than separated out into the separate tables. Denormalization, yeah, I just wasted your time. So everything we just talked about is essentially crap. This is the new way of doing things. Go ahead and throw everything you knew away. Web scale is it, right? Not really. It really depends. So when do you use each? When do you use a regular traditional SQL database? When you have sophisticated joins, when fidelity of the data is paramount, complex relationships that you need to create and query, when you have a static data model that's not going to change very much because you don't have to worry about migrations, when you have multi-row transactions that you need to accomplish, a less sophisticated DBA, and you can however, you can still boost performance with a lot of stuff through followers, slaves that keep the data and you can read across those. But when should you use a NoSQL database? Whenever you have complex data that you're saving. I mean, geospatial data is notoriously difficult to handle well within a SQL database. Well, when you have a data model that's constantly changing, a schema that's constantly changing, horizontal inconsistency is not necessarily an issue, and I'll give an example of where that might be the case. And there's some great features. If you are really focused on providing or building web apps, then there are some interesting features that are built into stuff like MongoDB, such as the op log. And you can actually create, there's a lot of libraries that create a WebSocket that connects to your MongoDB, and so you can just get updated information and query against it as a trigger. So when distributed read performance is critical, and this is what we were talking about, web scale, web scale, web scale, and you have a more sophisticated DBA that's willing to maintain, cleanse the data, normalize types, and things like that. There's a lot more that has to happen on both the programming side and also the DBA side whenever you're using NoSQL databases. So what's really the point of all of this? There's really no right or wrong answer, and they are not mutually exclusive. So just because your app uses a SQL database does not necessarily mean that you can't also use a NoSQL database depending on what it is. In fact, there are a lot of web apps that end up using some key value store like Redis, for example, to cache a lot of the database queries. So you can actually use Redis to back up your SQL database and SQL structure. And an example of where this might be useful is, let's say you're building an intranet for your system. Your comment system might be on NoSQL, but your actual HR system, because of the relationships and the complexity of those relationships, might make more sense on a relational database system. So quickly to get into abstractions, and this is kind of where we look at this notion of it being schemaless. So an abstraction, which I'm sure you guys have used very often, is an API or library which obfuscates some of the raw querying or manipulation of the database. Ruby has like active record, or Rails does, and then you have stuff like Propel, Doctrine, PDO. Laravel has their own version. Mongo has Mongoose and Monk. But it can, some benefit of it is because of the abstraction, you can actually drop in and out of other databases. So the application that you write, even though you may write it for MySQL, because you use an abstraction library, Postgre might be an easy drop-in replacement without you actually having to go and manipulate the queries or update those libraries at all. And some, and this is really critical, especially on the NoSQL side, some add validation and schema support to databases that might not have them by default. So you can actually go and add a schema to Mongo, your MongoDB, and it will actually error out if it doesn't follow that schema automatically, so you don't have to be programmatic and have those fallbacks built in. Now, some abstractions also offer data migrations, handling the table structure for you, and can even build your original data model from an existing schema. And that's really critical too. It saves you a lot of time instead of you having to go and define it. So the point of all of this is look forward and really don't be afraid to broaden your horizons. Right now, PHP is really entrenched on the MySQL front. Everyone likes, the hard schema SQL tables, and trust me, I understand it at all. It took me a while to wrap my head around the use case and have a rational basis for stuff like MongoDB. But your app will thank you, and it's really critical to always use what makes the most sense. And a lot of times you're not going to realize what makes the most sense until you've gone through the process at the very beginning of actually mapping out your objects, mapping out your data, and understanding those relationships. Once that happens, this becomes a lot more clear to you as to what database you should use, if not both, when and why. So, if we want to continue the conversation, I'd love to. My Twitter is just ETC, very easy. LinkedIn is eCook, and my email is e@law.fm. So, are there any questions? Yes, sir.
すいません。じゃあ、英語自信がないので日本語で。先ほどのプレゼンテーションの中で、スキーマレスのデータベースを選ぶ のはそのデータベースエクセレントな DBA が必要だというふうに
A schemaless? No, you don't necessarily need a DBA to do it. You can do it yourself. You just have to be aware that the data is not going to be automatically cleansed and ordered accordingly. How do I say this? You're going to need someone to make sure that all of the data follows your prescribed schema. Does it make sense? In the types, etc. Because if you try to save data in MySQL and it doesn't follow the schema, it rejects it. It says no. It won't save in the database. But with NoSQL, it absolutely will. It doesn't care what you save. It will just save.
I found that in your presentation, it seems that the excellent some developer needs to maintain the database in schemaless database. So, but in recently, I hear that many people adapt MongoDB or some schemaless database because they don't have good database experience, or they can't hire a good database administrator.
You're absolutely right. And in cases like that, there are abstractions like Mongoose and Monk, etc., that you can actually define your schema directly, programmatically, and those abstractions will actually reject and keep the data cleansed for you. So then you just define it once and it handles it for you, but it's not done at the database level. As far as the database is concerned, it will save and read whatever that you save to it.
How do you think about which is less cost to study relational database or schemaless database?
To study?
Studying cost. I hear that many people avoid relational database because it is hard to master relational database and database design, table design.
You're absolutely right. It can be hard to master, but I think that any good developer eventually has to learn it, because whenever you're doing queries, whenever you're designing those queries, whenever you're designing joins, you have to understand how those relationships and how those objects come together, or they may not be the most efficient, they may not be fast queries. So it's really critical that you understand how the data works together if you're designing the application.
Oh, makes sense. Thank you very much.
Thank you. Anyone else? Okay, well, thank you very much. And if you have any questions, come to see me after.